Hello everyone, greetings of the day. Today we are going to discuss the unit 5 of our curriculum, that is power quality problem in distribution system and CBEMA curve. We are going to discuss this topic in brief. Now we have discussed few things in the class that what is power quality problem. Now a power quality problem is an occurrence that is manifested as non-standard voltage, current or frequency deviation that leads to misoperation or failure of equipment. And power quality is the term that refers to maintaining nearly sinusoidal voltage of a distribution bus at rated magnitude and rated frequency. So these we have discussed in the class, that when the rated voltage, frequency, these actually deviate, or current, their magnitude and frequency deviate with respect to its standard form, we can assume it as a power quality problem. Okay. Now we have discussed so far that power quality problems are mostly these 6 types. They are transient, short duration voltage variation, long duration voltage variation, waveform distortion, voltage imbalance and voltage flicker. We have also discussed briefly what are they. Still I am going to discuss. We have also discussed in class what are these problems. Still I am going to discuss it again in a brief manner. Now this transient can be classified in 2 parts. We all know that the steady state operation, that is actually after switching of any device in a system, after elapsing certain a longer period of time, we assume that the system has been shifted at a steady state. But the transfer period, the initial period, we call it transient. So sometimes these transients are also referred to as power quality problem. Now this transient are characterized in 2 ways. So transient, if this transient is the problem, so if we consider the transient as a PQ problem, now this transient can be classified in 2 categories. One is called impulsive transient. And another type of transient is called oscillatory transient. Okay. So impulsive and oscillatory, 2 types of transients. And what are their methods of characterization? That is, we always consider the transients with their magnitude and duration of time. So they are characterized by magnitude, peak magnitude, how fast the magnitude has been, that means its rise time, how fast this transient appeared, it actually reached its maximum magnitude, and for the long the period it appeared, so time duration. So these three things are important to characterize a transient. Okay, so these are giving the characteristic of transient. So this is the characteristic of any transient. Now, what is oscillatory transient and impulsive transient? Impulsive transients, they are static transients. They give a sudden shift in the system, but they cannot move in the system. But so why impulsive transient occur? So the cause of impulsive transient, cause is the impulsive transient cause, that is like transformer switching. This is the normal regular system. We have transformer energization. We have discussed this in class, transformer energization. And if there is a sudden lightning strike, that is also cause impulsive transient. Lightning strike. Or you have switch capacitor in the system, so capacitor switching. So these are the causes of impulsive transient. Similarly, if you go for oscillatory transient, this is actually this impulsive transient cannot move in the line, but it creates oscillatory transient which actually moves in the line and create certain disruptions in the line. So the cause of oscillatory transient is also impulsive transient. Cause of oscillatory transient is mostly impulsive transient. Okay, and another thing is if you switch on a line or a load, or you switch on capacitor, that may cause also oscillatory transient. So these are the causes and characteristics of any transient. Now what I told you that how can you understand the peak of the peak of the impulsive transient? Suppose this is my normal sinusoidal waveform. Okay, so the peak, a very high peak occurs, and this peak is almost more than 3 to 4 times than the normal magnitude of the transient. So this is actually your impulsive transient, but this is static in nature and it cannot move into the system. But it will cause oscillatory transient that will move in the system. The oscillatory transient means this will cause oscillatory transient means the oscillatory transient peak is comparatively low, but it will create a oscillation within the system. Okay, and due to this oscillation in the system, which is flow through the line, and it will cause, due to as it has a high magnitude, naturally these oscillations will have high magnitude, and it may cause that there will be, we know that some insulators, that is because the line cannot be in a higher magnitude, it may create disruption of different elements in the line. So that will occur due to this oscillatory transient. So finally it is actually if there is a disruption in line, there will be a fault, and there will be finally a disconnection of power. So finally the transient may cause a interruption of power, which is detrimental for the especially for the industries. Okay, so these are in brief, these are the mostly the causes of transients. Okay, next category category is the next category PQ problem is short duration voltage variation. Okay, so short duration voltage variation. What are the short duration voltage variation? So next is short duration voltage variation. So this is the second type. Generally we consider the voltage sag, swell. These are the short duration voltage variation. That means if there is a dip. Why? Because what is the causes? The cause is large motor starting, large load switching. These are the mostly cause of voltage sag or dip. So voltage sag, this is caused due to large load switching, right? It may cause a dip in the voltage. It may cause a dip in the voltage. That means if this is the voltage for small period, there is a dip in the voltage. So this will be initially there is a dip and then again it will come to normal. So this is the dip in the voltage. So this is due to large load switching, motor starting, or sometimes for LG, that means line to ground fault. Okay, and here also how can you characterize this? You will characterize it by magnitude and the time duration. Similarly, the next is voltage swell. Next is the swell. Okay, and why? Because here what happens now, if you have put a capacitor switching on line, there may be a voltage swell for a small duration. The voltage may go up, so this is called voltage swell. And another is temporary interruption. Temporary interruption, you can understand this may be due to some fault. So third is temporary interruption. Temporary interruption. Now if you if you compare among these three, you will definitely the temporary interruption is much detrimental for the production, because in any case if there is a voltage sag, after few cycles the power interrupted power will come and it automatically starts, because initially there is a controller in the system. Due to voltage sag or even due to voltage swell, it will stop the system, but it stops it for temporary reason. Whenever there is when it goes up to the proper value, the system starts automatically. Okay, but temporary interruption is more detrimental, because what happens now, for a small duration current goes off, but here you have to start the whole process afresh. That means you have to again switch on the system, and from the first you have to start. So this is much more detrimental among this short three categories of short duration voltage variation. Now we will discuss about the long duration voltage variation. Now in long duration voltage variation, what happens, it is under voltage. So if we go for the next part, that is the long duration, going to the next slide. So if it is for long duration, so long duration means that the voltage is actually the voltage sag or swell, what we are calling here, it is actually appearing for a more longer time. right? So then we cannot call it a swell or sag. Here we will call it either under voltage or over voltage. And another is sustained, and if this is a temporary interruption, that is a trip of the line, if it is for a longer duration, we will call it sustained interruption. So longer duration, that will be under voltage, over voltage, and sustained interruption. Okay, the causes, you can understand that the suppose if more number of loads are there in your system, that may cause the voltage profile low. Okay, in a distribution set, the number of end users on that line is so high that it makes the voltage profile low, and that is actually the cause of under voltage. And similarly here also the characterization is the magnitude as well as the time duration. Now over voltage is, suppose you switch a capacitor on the line, and suppose switching off a large load also may come, and if a capacitor you put it on the supply it from a capacitor so that may also come under the, it may create a over voltage in the system, so and that will be the reason for over voltage. And sustained interruption, definitely it will be the fault where you may not have power for a longer period of time. So we will discuss the next problem, that is voltage imbalance. We also discussed this in class, still we are discussing it, that what are the voltage imbalance. That means the reason of voltage imbalances are mostly single phase loads, in their distribution in the load system, if they are not what should I say, these loads, suppose the loads are in the system, if they are not properly distributed, right? Suppose the RY be 3 phases, and if in the R phase the number of consumers are more than Y or B phases, naturally there will be a imbalance. It will be not a balanced supply and it will create an imbalance. So that is one of the reason for voltage imbalance. And another is single phasing, we also discussed this. That means suppose a motor is running in the supply, a 3-phase motor. If one phase goes out, only 2 phases remaining, and the motor draws current through only 2 phases. This phenomena is known as single phasing, and it actually creates heating within the system and will create imbalance in the system. So these are the factors which cause single voltage imbalance. And how we actually improve this single phasing, it by virtue of symmetrical components. We know symmetrical components is a method to handle imbalance in the system. So the characterization, that is, if there is imbalance in the system, we actually use symmetrical components for our analysis. Next is our 5th part, that is the waveform distortion. So next power quality problem what we are going to discuss is waveform distortion. Okay, so the next is waveform distortion. So you can understand from the term that the waveform distortion means that there is a distortion in the waveform. That means suppose my waveform may be like this. It may be like this, or there may comes harmonics in the system that will suppose that will change the shape of the system, like suppose like this, or it should be the shape is changing like this, suppose like this. Okay, so the shape of the waveform distorts, or there may be a DC offset in the system. That means there is a shifting in the line. So this is zero line. What is happening? Our magnitude is lowering in this way. So this is bigger, this is smaller. So in this way, these are three sets of waveform distortion that can appear due to power quality problem. So one is, this is called notch, this is harmonics, and this is DC offset. Okay, so now what are these problems? The problems that this harmonics, you know, if a system, if the load becomes non-linear, that means if there is a system, simple, if I draw with a single line diagram, this is a system where the load is actually not a linear load, it's a non-linear load. Okay, so it's a non-linear load. So due to this load, what will happen? The current within the system, the voltage is absolutely perfect, it is a sinusoidal, but the current, when it is flowing within the system, this current will distort from okay, and the current will distort from its regular wave shape, and we will call it that it is containing harmonics within the system. So what is happening? Why it is happening? Because we know a non-linear thing means where linear means where the voltage and the current, it goes in a proportionate way. Okay, it increase in a proportionate way, whereas a non-linear thing means the voltage and the current, it is increasing in a disproportionate way. So it may be like this initially, suppose it is linear, then there comes a saturation or something. So here from this point you can understand the amount of current and voltage, there is a difference. So the voltage and current, they are changing the values in a different way, disproportionate way. So what is going to happen? Though the voltage is perfectly sinusoidal, it is creating the magnitude of current which is not perfectly sinusoidal. Somewhere the increase of current is more. Okay, so it may happen that the increase of current with respect to the voltage is more, and then like this, the wave shape of the current may change. So this type of wave shape will contain harmonics. So though the supply voltage is perfectly balanced, due to non-linear load, the current becomes different. Okay, so that is the reason of now what is going to happen then? So what is going to happen if in our system, if there is a non-linear load, we know that here generally what happens, if is my system, the loads are connected to a point of common coupling. This is the bus, the supply side bus, and this is the load bus. Okay, so we call it PCC, point of common coupling. So from here the loads are connected. All the loads are connected in parallel in the point of common coupling. So there may be a perfectly linear load, there may be a non-linear load too. Okay, so the loads are connected over here. Some of it are linear, some of it are non-linear. I should change the symbol. Suppose this type of wave, this is a non-linear load. So whenever the current is also and the system has some inductances, right? Now if the system though this voltage is perfectly sinusoidal, what is going to happen, as the current is non-sinusoidal, it will create a drop over here. So when you subtract these from Vs, what is going to happen, at VL the load voltage will not be sinusoidal anymore. Understand? So though the supply voltage is perfectly sinusoidal, as the current is becoming, due to nonlinear load, as the current is becoming as due to presence of nonlinear load, naturally the current will not be sinusoidal, so it will create the drop across the line, which is obviously not proportional, and naturally the end voltage will become deviate from its regular nature. So that is why the voltage across the loads, all the loads, even for the linear load also, the voltage will not be regular sinusoidal anymore. Okay, so due to this consumer, actually all of the consumer will suffer. So this is also a power quality problem, where actually the distortion of waveform may occur. Now due to this nonlinear load, what will become, harmonics may appear. So the system, that this wave shape will change. And how can we calculate them? We used to calculate by THD values. What is THD? This is called total harmonic distortion of the system. Okay, so total harmonic distortion of the system, by using THD value we can measure the harmonics. Next point is notch. So this was harmonics. Why harmonics appears in the system? Why this appears? Due to non-linear load. What are the non-linear load? The non-linear loads are mostly your power electronics systems, power electronic converters, etc. Okay, because the semiconductor material are non-linear, they are naturally it gives a non-linear effect in the system. Now next is notches. So notches is also a reason or result of non-linear load or power converters, mostly because in a power commutation appears in power electronic devices. Two types of commutations are there: force commutation and natural commutation. And in the time of commutation, what happens? So it is actually the process of handling the devices, the conduction from one device, one diode or rectifier to another. So what happens here mostly, that for a very small duration of time, this two devices conduct simultaneously, and it will create for a small time, it will create a problem in the system, or short circuit in the system, you say. So that will create notches in the system. Okay, so this type of notches appears due to power electronic converters. So sometimes these notches are very deep, and it may create power absolutely power loss for a temporary time duration. So these are the basic things, and it generally occurs due to the rectifiers or power converters. Okay, so next is the DC offset. Why DC offset occurs? DC offset also occurs due to power converters. The shifting of the due to some reason the unipolarness deviates, sorry, the bipolarness, the zero deviates, it deviates. Okay, and what happens now, this deviation occurs like this happens that this suppose becomes more in the lower side or vice versa. So this type of, if there is a change in offset, that is also considered as a power quality problem. So we are almost at the end of the problems. The last problem is our voltage flicker. Voltage flicker, you can understand that there is a flicker of voltage, and it is mostly the interference of the frequency, because we have voltage flicker, we have a certain frequency. Okay, 50 hertz, this is our frequency. Now any other frequency, if it interacts with this higher frequency, interacts with this will create a problem like flickering. Okay, so what if that is why frequency of occurrence and a modulating frequency will create voltage flicker in the system. So these are the power quality problems in distribution system, very briefly discussed. I will discuss the CB-EMA curve in a next video. Thank you all. Happy learning.